Uh, we are going to start by looking at this setup. Okay, there is a coil over here. Can you see the yellow coil?
Yes.
It is connected to a device called as galvanometer. What is a galvanometer? We'll come back to it. This is a coil and there is a magnet, and I'm going to do something with the magnet and see what happens in the galvanometer. So what a galvanometer does is that it detects the presence of current. Means whether current is there or not there. That is one purpose of the galvanometer. Other thing that the galvanometer does is that it will show you which direction the current is flowing. If the current is flowing over here, the galvanometer will point in one direction. If the current is flowing from here, the galvanometer will point in another direction. Okay? And when no current is flowing, the galvanometer is going to be at 0 over here. Clear? So, like we have a number line 0, 1, 2, 3, 4. On the other side, there's -1, -2, -3, -4. Makes sense? Like that. When there is no current flowing, the galvanometer is at 0. When current flows in one direction, the galvanometer is over here. Current flows in the other direction, the galvanometer goes in the other direction. Makes sense?
Yes.
Now I'm going to explain you the observations, and then you are going to think of what is exactly happening. Okay? There is a coil, there is a galvanometer. Is it connected to battery?
No.
No, that means there is no current flowing in it, right? There is just a coil and there is a galvanometer. I'm going to take this magnet, there is north pole and south pole of the magnet, and what I'm going to do is I start with the magnet over here and I bring the magnet closer. Okay? What happens when the magnet is brought closer is that the galvanometer suddenly shows a deflection in its needle. That means what must be happening? Current must be flowing. Okay, now as long as the magnet was moving from here to here, the galvanometer showed a deflection. The moment I came here and I stopped my magnet, the galvanometer went back to 0 and stopped over here, there. Which means what must have happened? Current is not flowing. Now, from here, I move the magnet back that way. The galvanometer needle shifts, but it shifts in a opposite direction. Earlier it had shifted here, now it has shifted here. What do you think must have happened?
Current is passing left side.
As compared to the first thing, what must have happened? Anybody?
Current is flowing.
Current is flowing, but
The direction of the current
Yeah.
change.
direction of the current changes, right? So the direction of the current is dash as compared to the previous time. Opposite to the last time. Okay, I will explain the experiment again and I'll explain it to you again, right? Magnet is coming this way, galvanometer deflected this side. I stopped the magnet, the galvanometer came back to 0. I took the magnet that side. As long as the magnet was moving, the galvanometer showed a deflection in the other direction. Okay? And when I went and stopped the magnet over there, again the galvanometer came back to 0. Okay? Now we are going to start thinking about what is the difference. We are going to start thinking about why is this happening, right? Why is the current coming and what is this related to? Like why is this happening? Can someone raise their hand and tell me कि ये किस वजह से हो रहा है? Like why was there current? What did you see was changing, or who is causing that current to come in the coil? Anybody apart from Kajal? Yes, Arjun.
I think magnet is causing current.
What about the magnet is causing current? Can someone think more and give answers? Yes, Vipin. What was causing the current? Like what exactly? Did it think about the entire experiment? Yes, Kajal.
I think that the direction of the magnet was causing current.
What do you mean? Can you elaborate a little more? Direction of the magnet. What does direction of the magnet
Like wherever the magnet goes,
goes? Can I use a better word for it? What of the magnet was causing the
Moving of
current?
the magnet.
Moving, can I use a better word? Movement of the magnet, right? Exact word over here. Why was I saying the current? Because the magnet was moving. And why do I think it was because of the movement of the magnet and not just because of the magnet? What showed me in the experiment that it was because of the movement of the magnet and not just because of the magnet? Yes,
Because
Anand?
here when you stop the magnet, the galvanometer was at 0.
Excellent. When I stop the magnet, the galvanometer went to 0. That means that this current that was flowing was because of the movement of the magnet and not because of the magnet itself. Does that make sense?
Yes.
What we just saw was the movement of the magnet was causing a current in the coil. When the magnet was moving in one direction, the current was in one direction. When the magnet was moving in the other direction, the current was in other direction, right? And when the magnet stopped moving, the current also stopped. Make sense?
Yes.
All of this is clear. Now, because of either the movement of the magnet or the movement of the coil, I could either move the magnet or I could either move the coil. There is a current that gets induced in the coil. Induced means it's generated inside the coil. Okay. And that is called as electromagnetic induction. Induction means the current comes inside, it's induced inside the coil. Why? Because of the movement of magnet or the movement of the coil. Okay. So here I am actually moving something because of which current is being generated. Is that clear?
Yes.
Basically, this is Fleming's right hand rule, so I am going to use my right hand. Okay. Again, like last time, my index finger is going to point towards the magnetic field. Like last time, index finger pointing towards the magnetic field. Motion of the conductor, where I am moving the conductor. Here we move the magnet, but you can also move the conductor. The motion of the conductor will be given by the thumb, and the middle finger is going to give us in which direction the current will flow. Okay. So for current to flow, there are two requirements. There should be magnetic field and there should be motion of the conductor. If these two are there, then my current will flow in this direction. Is that clear?
Yes.
So again in Fleming's right hand rule, this direction of motion of the conductor and direction of magnetic field are perpendicular to each other. These two are perpendicular to each other. This and this is perpendicular to each other. These two perpendicular to each other. These two perpendicular to each other. This and this also perpendicular to each other. Make sense?
Yes.
We are going to start with learning the working of an electric generator. I have a north pole and south pole of the magnet, and in which direction is the magnetic field?
Left to right.
Left to right. From north pole to south. This is a coil over here. It has left side AB, other side is CD. This coil, the AB side of the coil is coming and ending over here in ring B1. This is a B1 ring. Yeah. The B1 ring stays at one place. Okay. And the AB side of the coil is coming and ending over here. Can you see that?
Yes.
Very clearly. It's still here. Okay. Blue color. CD side of the coil is coming all the way till here to the B2 ring. Can you see that?
Yes.
This is coming blue color till here. Clear?
Yes.
AB side of the coil is coming here. So when the coil is rotating also, this side will rotate in the B1 ring, this side will rotate in the Is that clear?
Yes.
Are you clear with me? CD side of the coil is going to move inside the B2 ring, right? Because this is coming till here and this is kept till here. This is perfectly clear?
Yes.
Yes.
Okay. Now I am going to mechanically move this coil. Okay, the coil is not moving by itself. I am going to mechanically move this coil. Now who moves this coil or how this coil gets moved, we'll come back to it sometime. But this coil is being moved mechanically, clear? And there is magnetic field, north to south. Is it connected to any battery or anything? No, because our purpose is to generate current, okay? What is this over here? Galvanometer over here. So galvanometer is going to show me whether current is generated or not and which is the direction of the current. The galvanometer is going to show me both things, whether current is generated or not and which is the direction of the current. If there was no current generated, where will be the needle of the galvanometer? At zero. If current is generated in one direction, galvanometer will shift here. Current is generated in other direction, galvanometer will shift here. Now, as this, let's assume that this coil is being mechanically moved in the clockwise direction. Can you see this direction?
Yes.
Okay. So, let us look at the left side of the coil. Let's focus on the left side of the coil. Left side of the coil is moving in which direction? Upward or downward? If the entire coil is moving clockwise,
Upward direction.
left side of the coil is moving upward. Make sense?
Yes.
Okay. I'll use my right hand. Index finger is pointing in the direction of the magnetic field, which is where? North to south, right? Here?
Yes. Yes. Yes.
Clear?
Yes.
Movement of the coil, which direction? Movement of the coil.
Upward.
We are looking at the AB part of the coil. It's upwards, right? And my middle finger is going to give me the direction of the induced current, which is which direction right now?
Inside the board.
Inside the board. So in which direction is the current going to flow over here? This way. Yeah? This is not upward. Like last time, I'm again explaining you. This coil is like this. For you, if I draw it like this, you will not see the coil. Therefore, it's drawn so that you're viewing it from here. Is that clear?
Yes.
So this is the coil. It's moving upwards. The left side AB part of it is moving upwards. My magnetic field is in this direction. The coil is moving upwards, so the current is going to flow in this direction. Is that clear?
Yes.
Yes.
Now, forget about the left side of the coil. We are going to look at the right side of the coil, CD. Okay. Faizan, which direction is the magnetic field? Left to right. Right. Which direction is CD part moving? Yes, Nitin? Downwards, right? Because it's clockwise. This part will be moving downwards. So, which finger should I point downwards? Which finger should I point
Thumb.
downwards? Thumb. Thumb shows the direction. And which direction should the current come? Outside the board. Is that clear?
Yes.
So, here in the CD part, the current is flowing outside the board. Is that clear?
Yes.
Again, I am showing this part CD is moving downwards. Magnetic field is in this direction. Since CD is moving downwards, I point the thumb downwards. My middle finger is going to give the direction of the induced current, which is coming outside the board. Is that clear?
Yes.
So this current is flowing A to B, B to C, C to D. From D, where will it go?
B1.
To B2. Is that clear?
Yes.
So from B2, it will come over here. Will the galvanometer show a shift in a particular direction?
Yes.
It will come back over here. It will go to B1. Make sense?
Yes.
So current over here flowed from B2 to B1, and in the coil, it is flowing in the direction A to B to C to D. Is that perfectly clear?
Yes.
This was like this. It made a half turn and it became like this. It was like this. Made a half turn and became like this. So this is showing this part of it, right? The CD which was there has now come over here. AB has now come over here. Does that make sense?
Yes.
The CD part is still in B2. It moved from, it was earlier here, it moved to here when this made a half turn. Here?
Yes.
End of CD. End of AB is still in B1. Make sense?
Yes.
Now let's apply Fleming's right hand rule over here again. Adiba knows which direction is the magnetic field?
Left to right.
Left to right. Okay. CD part is moving in which direction? It's still moving clockwise, right?
Downward.
CD is moving upwards, so thumb pointing upward. Which is the direction of the
Inside the
current inside the loop? So current is moving from A to C. Let us look at the other side. Muskan, which direction is the magnetic field? Left to right. Okay. Which direction is BA moving now? Downward. So my thumb goes downwards. Which direction is the current now? Outside the board. So now current is going from D to C, C to B, B to A. From A, where is it going? B1. So from here it will go this way and come back to B2. From B2 it's going back here. Clear? Will the galvanometer show a deflection?
Yes.
Will it show a deflection in the same direction as here?
No.
Why not? Because here the current was flowing this way. Here now the current is flowing this way. Does that make sense?
Yes.
So when this coil moved this half turn, when the coil moved this half turn, the current was flowing in one direction. When the coil moved another half turn, the current started flowing in the opposite direction. When the coil now moved again this half turn, current again switched the direction. Coil moved another half turn, current switched the direction. So what is happening with every half turn? The direction of the current is changing. So how will the galvanometer show shifting? Exactly as Shania is showing, right? It will keep showing deflections on both sides. Every half turn, as the coil is moving every half turn, the galvanometer is showing deflections on both sides because the direction of the current is going on switching. Does that make sense?
Yes.
When this coil was taking the first half turn, my current was flowing from A, B, C, D and then B2 to B1. When in the next half turn, the current is flowing from D, C, B, A and from B1 to B2. Okay, so every half turn, the current is switching. Now, why is this happening? Why is this current being produced? The main reason for the current being produced is that this coil is being mechanically moved, right, in a magnetic field. So what are the two things that are essential? One is the magnetic field that is essential, and second is the movement of conductor that is essential, right? Index finger giving magnetic field, thumb giving movement of the conductor. Both things are essential. Now, how do you think this conductor is, this coil is moving? Like, who is mechanically moving the coil? Yes,
There
Kajal?
would be a motor or some gadget.
There will be a motor or some gadget. Anybody else? Atul?
Yeah, I think someone moves the और फिर बाद में जब करंट फ्लो होने लगता है तो वो अपने आप घूमता रहता है और
अपने आप कैसे घूमता रहता है? कोई भी चीज अपने आप घूमते नहीं रही. अगर मैं एक if I turn on this fan and say that okay, I'm giving you initial supply and then keep moving, it's not going to keep moving. And am I going to employ a person who is going to be 24/7 without stopping, keep on moving this again and again and again and again, and we are getting electricity, we are getting electricity? Achal?
Yeah.
No. Muskan? No, induced current we are using. No, we want to produce electricity.
I think yeah, because of the wind it moves.
Because of wind. How?
जिधर इसको रखे होंगे उधर बहुत ज़्यादा हवा चल रहा है फिर उससे मूव होता है.
Okay. Yes.
There must be a switch.
There must be. So we use electricity to generate electricity. Then what are you getting out of it? I'm moving this by giving electricity and I'm generating electricity out of it. Yes, Vipin? Windmill, right? Where did you study this? Where? You did a project, right? So windmill can be one thing that can be used to move. Now answers will start coming. Yes, Anshul?
भैया आई थिंक भैया जो ओशन हाइड्रो
हाइड्रो
हाँ हाइड्रो पावर वुड बी कनेक्टेड
Hydropower is an ocean. What is hydropower?
नहीं
What is
डैम
hydropower?
डैम में रहते हैं
Dam से पानी. You all made all this, no? You all
Yes.
made all this turbine and all. You all did windmill, right? So, windmill and hydropower. What else can I use? Tidal power. What else?
और
What else? These are called renewable energy sources, right? These are we are looking forward to transition to these sources later in future. Currently, what gets used mostly? How is this electricity?
फॉसिल
Heat
फ्यूल
from where? Fossil fuels. How? How fossil fuels? Yes, Ronak.
When we burn coal,
Yeah.
वाटर
water in
स्टीमर
the water gets heated up
Yeah.
and it makes heat.
Excellent, right? When you are heating, when you are burning coal, you heat water through it, you generate steam. That steam is going to run a turbine. That turbine is connected to this coil. Make sense?
Yes.
That is what is rotating the coil, generating electricity.